Hey everyone, let's start with question number 19, Digital Electronics, asked in GATE Examination 2025, Computer Science and Engineering, branch set 2, afternoon. The question says, in a 4-bit ripple counter, if the period of the waveform at the last flip-flop is 64 microsecond, then the frequency of the ripple counter in kilohertz is. The catch of this question is the frequency of the ripple counter. It is asking for the input frequency which is supplied to the ripple counter. Now let's draw the ripple counter and see what we get the answer. This is a 4-bit ripple counter. So we have 4 flip-flops connected asynchronously. As the question state, it is ripple counter. Ripple counter means asynchronous. That's why it is always known as a ripple counter. Ripple means I would tell you about the exact meaning of ripple. It means accumulation of delays or anything else that could be accumulated as the number of flip-flops increases. So everything which is accumulated with the increase in number of flip-flops, most common part is the delay. Delay gets accumulated one after another just because one flip-flop is connected to the other. That's why it is referred to as a ripple counter. Now let's have the connections. So we get the input. Let's consider a D flip-flop. So this is the output. Now this gets the input. I am assuming it to be as a positive edge triggered flip-flop. Now this gets the input D, Q. This gets the input D, Q. So what happens? Let's write Q bar, Q bar, Q bar, and the final output. So these are the output nodes. Node 1, let's say this is flip-flop 1. This is B and C and D. This is output node 1. This is second. This is third. And this is fourth. Although there are 4 output nodes, but question is asking for what will be the frequency of the ripple counter. It is asking about this frequency, not the most of the student thought that it is asking for this frequency for this. The question looks like that it is asking for the frequency of the ripple counter, but this statement tells you about that the input frequency which is supplied to the ripple counter, or we can say the frequency at which ripple counter is working, and which is this frequency. What information else we have got? That a last flip-flop is 64 microsecond. So if the frequency is at the input is f, then we got the frequency here to be f by 2. Then we got f by 4, f by 8, and this here is got f by 16, because for the next flip-flop the frequency I can just tell you for one flip-flop, although it will take much more time. So if you consider a positive edge triggered flip-flop, a positive edge triggered, so this is your clock. So at positive edge your this flip-flop works and this goes high and it will remain high, this goes low, this, and now this becomes the frequency. If it has f frequency of clock, then this becomes f by 2, which is suggested here. Now this becomes clock for another flip-flop, and now again further if we draw the in clock of output of another flip-flop, which is this, so you will get like this, because for flip-flop B this point is acting like a clock, so this is acting like a clock for this. Similarly for the last one, so it will take much more time. So I think you got my point. Now f by 16 is the frequency of the last flip-flop, and the question is given about the time period. If the frequency got half, then the time period will, if it has time period t, then it becomes 2t, 4t, 8t and 16t. So 16t is equals to how much? 64 microsecond. The t becomes 4 microsecond, and we got the t, so f is equals to 1 over t, which is 250, and the answer is asked in kilohertz. It is 250 kilohertz. This is the answer of this question. Thank you.